Hello, welcome my dear students. This is going to be the fourth lecture of 7th week. In the last few lectures, we basically worked out on medical waste, the nature of those different kinds of medical waste, as well as in the last class, we mentioned about their particularly, once it is being segregated, because that is very important job in the whole process. And once it is being segregated, then the next course is it has to be packaged and leveled. And this leveling is very, very important. Whether you tag those particular barcodes or put all those important details, who is sending and to whom it is being sent. So every details once it is being mentioned in that particular package. So and also we talked about that what is the nature of the way it is to be packaged and the material which one is going to use particularly as a packaging material. And once we are pretty sure of all these things, definitely the next course of activity is definitely storing as well as transportation. So in today's class we are likely to see that how it is being stored as well as it is being transported to that particular place or the desired place for its necessary processing. So in today's class we are going to talk about the storage of biomedical waste, as I already mentioned, the transportation of biomedical waste for treatment of biomedical waste. So there are number of or numerous ways to do that. So there are some sophisticated technologies also, and there are few normal or conventional technologies like simple incineration. So sort of things are also there. And then technological advancement, there are few technological advancement which has been made in this particular sector, as well as we'll talk about the record keeping and compliance, which is very, very important, particularly once somebody is doing this sort of operation, he has to maintain that particular record as well as it has to be as complied by the necessary, whether you talk about the local government agencies or maybe at the state level or maybe at the central level. So whoever is giving that sort of regulations, that has to be maintained. So we were mentioning mostly related to, we started with this particular part of waste management team. We talk about the composition of that particular team, that what would be the composition, who is going to take the lead and who is going to do all sorts of liaison with all the stakeholders, because this is a long team and everybody has a definitive role to play. And then you need to have a waste management, a substantiate waste management plan in place, and then definitely training and sensitization of these people who is involved in this process, which is very important, starting from medical practitioner to the handler who is going to handling this particular waste or transporting this particular waste. So they should be make aware of all those particular protocols and regulations as well. And then we need to have a very once our team is being formed, definitely the survey is very, very important, because that survey is going to give you some sort of sense that what is the state where we stand basically right now. So what is the limitations, right? So that can be done. And then finally our works get started basically once we talk about that segregation. We also mentioned that, and this segregation is very, very important, and it has to be put into those different colored labeled bins, which signifies the importance of, we also discussed the significance of those colors. And then the collection and categorization of waste is basically once it is being collected and then it has to be categorized, as I mentioned already, then it is going to be labeled, and those labeling is very, very important, because if somebody wants to track of all those operations which is happening throughout this particular process, definitely that labeling is very, very important, and where barcode will be a very, very important tool or which is going to assist in the whole process. So today what we are likely to extend our understanding related to this particular storage waste. storage of this particular waste in respective containers, right. We also mentioned that in the last class, and then we will be talking about transportation and treatment. So, these are the few parts which we are likely to talk about. So, whenever we talk about the storage, definitely there are, in few cases you have interim storage. Interim storage of biomedical waste is basically discouraged in the wards or different departments of the healthcare facilities, or maybe in the research unit. If that particular waste is needed to be stored on interim basis in that particular department, it must be stored in that particular dirty utility sections. It's not, it's not in the common place. One cannot put it in that particular place. No waste should be stored in patient care area and procedures area, particularly such as those operational theaters and all those particular area where it is very, very sensitive, because as I mentioned multiple times, that these are the source of multiple infections. So, there may be very important infections like some of those microbes I mentioned in the earlier class, whether it is mediated by bacteria, right. So, bacteria is always going to be dominant, and followed by, in some cases you may have some sort of other group of organisms which are also involved in that particular process. So, that is very, very important, whether you talk about those infectious, semi-infectious material. So, all infectious waste should be immediately removed from such areas, and particularly where the operations, particularly whether you talk about those technicalities of operations, or whether all those starting from treatment, starting from diagnosis area, and starting from anything, even the places where immunization is being given, you cannot keep it. In absence of dirty utility sections, such as this particular biomedical waste must be stored in designated place away from patient and visitor traffic or low traffic area. This is a must. So, these are, you can see over here that these are those particular interim storage sort of thing, or those temporary storage, as well as you have some permanent structure for keeping those particular things. And there are I mentioned about that interim storage, and then you have a central waste collection room, particularly for, this is a designated area basically. The location of central waste collection room must be away from your public or visitor access. The space allocation for this particular room must be as per the quantity of waste is generated, and the nature of waste sometimes, if it is of more of organic, or if it is more of any other lethal thing, which is whether it is heavy metals or radionuclides. So, definitely it is going to be different. The planned space must be sufficient so as to store at least 2 days generation of waste. At least it has that sort of capacity if that transportation agency for some reason didn't come. So, definitely it is capable to accommodate that much amount of waste. And this central waste collection room must be roofed and manned also, and it should be under lock and key under the responsibility of those designated person, because I said whether whoever is keeping that records as well as that particular storage records, and the nature of that particular waste, that is a designated person has to be authorized, and he should be given that sort of responsibility. The entrance of this center must be accessible through a concrete ramp for easy transportation of your waste collection trolleys. And then flooring should be tiles or any other glazed material, so it slopes so as to ease the cleaning of the area. So, definitely these are few those engineering aspects which actually enhance the efficiency of keeping those waste particularly. And this exhaust fan, which is very important, exhaust fan should be provided in the waste collection room for ventilation, and it is to be ensured by the healthcare facility that such central storage room is safety inspected for potential fire hazard, and based on such inspection, preventive measure has to be taken by the healthcare facility, like your installation of fire extinguisher or smoke detector, that has to be there. And there should be also provision for water supply adjacent to waste storage area for cleaning and washing of this station and the containers, time to time. This on time interval it has to be done. And the drainage from the storage and washing area should be routed to your effluent treatment plan, and that is again this particular effluent treatment plan has to be has to move through further treatment processes as well. And then signboards indicating relevant details such as the contact person and the telephone number should be also provided, and all details should be given. At least people should be aware that yes, these are those areas where this particular waste material is being stored. The entrance of this station must be labeled with entry for authorized person only, because these are very sensitive areas I am mentioning from the very beginning, and logo of biomedical waste hazard has to be given as well. So, and once it is being stored at that particular time, the next course of action is always going to be your transportation. So, it is a very, very critical step in the particularly waste management process, ensuring your safe movement from your healthcare facilities or those research facilities to your treatment and disposable sites, right, wherever it is going to be disposed. And proper transportation definitely minimizes the risk of contamination, the infection, as well as environment hazards. So, there are some pre-transportation preparation is needed, which is very, very prerequisite for this to happen. So, you have a segregated, whether it has, one needs to be very careful about that, whether those waste has been segregated properly, whether it is being labeled, clearly, or it is whether those secured and it is being sealed. That means bags and containers should be tightly sealed to prevent any sort of leakage during that particular transportation, and recorded in a logbook, and a proper logbook, because whoever is making that sort of audit in near future, definitely everybody will looked into those logbook, particularly when, what is the date particular, and which nature of waste is being transported, who was handling those particular waste, and to whom it was sent. So, every details was will be mentioned at that particular point of time. And then very importantly, the type of transportation methods. If it is internal transportation within that particular healthcare facility, waste is collected for different hospital department using trolleys and carts, means if it is internally being done, or bins, and collection should be scheduled regularly to avoid waste of accumulation, either in a single day, maybe once, or maybe within a day, maybe based on the nature and the quantity of waste is being generated, maybe twice or thrice it can be scheduled. Only trained personnel should handle this particular this or transport this particular waste. This is very important. And then if it is once that internal process is being done, definitely it has to be make ready particularly for your external transportation. And basically the objectivity is we wanted to reach those particular waste material to your treatment facilities. So, waste is transported to a designated treatment plants using specialized vehicles. Healthcare facilities may use in-house transport service or contract some authorized waste handlers. So, there are a few, these are all now being customized, and every facilities are there. So, you need not to make any specific arrangement for these. So, only you need to find out those vendors who will be collecting and who will be reaching those particular waste to that designated site. So, vehicle requirement for biomedical waste transport. So, what are those requirements or the requisites particularly of your vehicle? So, dedicated waste vehicles used only for biomedical waste transportation, it should be like that, means it is not can be used for some other reasons also. Closed and leak proof design prevents spillage and exposure to external environments, because if at any point of time it is going to move either to your soil or water or air, definitely it is going to make enrichment or impairment of those particular health of whether you talk about soil, whether you air, or whether water. So, then compartmentalization, that is very, very important. That means it has to be in several compartments. So, that compartmentalization is very, very important. That means separate sections for different waste types, and proper ventilation and disinfection ensures safety and reduces your odors, because this is very important, because during the transportation, if it is stuck in any traffic, definitely it can give rise some sort of bad odor. So, definitely if one is well ahead, made those sort of sanitization or disinfection, definitely it is one can get rid of that, and clearly marked with biohazard symbols, which I mentioned initially, that it has to be done with, so that alerts people basically to the nature of those hazardous nature of the load and the nature of that particular waste material, and transportation guidelines and safety measures, regulatory compliance. So, these must adhere to the national and international biomedical waste transportation laws, because every details have been mentioned in that particular law, whether you talk about those biomedical waste laws 2016 or other the international agencies, they have also framed those laws. So, every details are there. GPS tracking and monitoring, I was talking about that particular tagging, and once you have that sort of tag, and definitely you will be able to make sure that where it is now located. Those barcoding is definitely going to help you. So ensures route tracking and timely waste disposal, protective gear for your handlers. Transport personnel should wear necessary prerequisite things like your gloves, your mask and your protective clothing. And then emergency preparedness. Vehicles should carry spill kits, first aid and contact details for emergency response, because at any point of time there may be multiple situations which you never know that may arise. So definitely all these details are needed. Now once it is reached to that particular destination, once you are able to send those particular waste material to that particular designated place, definitely different treatments are available, different treatment options are there. So this proper treatment of biomedical waste is essential basically to reduce your environmental hazards. I was mentioning that particular, if at any point of time it is going to make entry into this, any part of these natural resources, definitely it is going to make, the impairment or the health is going to be impacted, and health risks followed by definitely, because it is containing those infectious material, definitely it is, you have a risk of health. And various techniques are used, whether you talk about thermal, you talk about chemical, you talk about biological, irradiation and mechanical methods. So, mostly in most of the cases and many a time, the choice of these particular methods is based on the resources which you have. So if it is being a thermal treatment, it uses basically heat to destroy your pathogens and reduce your waste volume. It includes maybe incineration. As several times I mentioned about this particular technique, a high temperature process, 800 to 1200 degrees Celsius, that burns waste, converting into ash and gases as well, right, and effective for pathological and pharmaceutical waste basically. And many a cases it can burn those particular infectious disease containing propagules also, and can release harmful pollutant. This is only the drawback, because if you are burning those waste material which is rich in plastic, right. So if it is rich in plastic, definitely it is going to emit this dioxin and furan, and which is not, and this is going to make a chaos in your ecosystem if it is not properly controlled. Then modern incinerators use basically air pollution control devices to minimize this particular emission. And then you have another mode which is most commonly used, basically autoclaving, particularly any healthcare facility, they always use this sort of mode. So they uses basically steam under pressure 121 to 134 degrees Celsius to sterilize your infectious waste or those sharps which is being used particularly during the treatment process or during operations, and common for treating laboratory and surgical waste like your contaminated plastic, your bandages and lab cultures as well, and environmentally friendly as it doesn't release any harmful gases, because within this particular temperature range, but it has some limitations also, because the amount, the capacity, it can make those sort of processing is always going to be an important issue. So whether you talk about thermal incineration, so these are bigger plants, and this you can see those autoclaving system. So the other method is your microwave treatment. So definitely once you are going ahead for your microwave, definitely you are reaching high temperature. That means you are uses your high frequency of microbes to heat and your disinfect basically your waste, uses microwave energy to kill pathogens in waste, and reduces pathogen effectively, but requires your pre-shredding of waste. That is important, that shredding is important before going ahead for this particular technique. And then you have your hydroclaving. This is basically related to your autoclaving, but uses rotating blades for better mixing and heating. So this is mostly particularly one can use this sort of instrument. And then finally you have your chemical treatment. And chemical treatment basically it involves use of disinfectants, whether you talk about chlorine, ozone and your peracetic acid, to neutralize your pathogen. And this is effective to liquid biomedical waste such as blood and your laboratory effluents which is coming out during those operations. So used for sharps and medical instruments before disposal. This is very, very important, and then can generate harmful chemical byproducts if not properly managed. So this has also some limitations as well. And you have your biological treatment, that means uses microorganisms, right, or enzymes to degrade this biomedical waste, because many cases it can reduce that time as well, still in experimental stage because it's in infancy stage, and has potential for sustainable waste management. Because going ahead for incineration or going ahead for any sort of temperature mediated treatment, definitely it is going to give rise that sort of undesired material, right. But example include using bacteria to decompose organic medical waste. Yes. So definitely those particular waste which is rich in organic resources, definitely there this mode, particularly this biological treatment, can be used, but still there are many ethical issues, as well as as I mentioned that this is at infancy stage, it needs further refinement of those existing one, means what can be done and what best can be done, right. The other mode is your irradiation. This is basically a non-thermal treatment using your ionizing radiation, whether it is gamma rays or electron beams, to destroy those pathogen. Highly effective, but requires expensive equipment and safety measures as well. Means you need very specialized person to use of those particular resources for making those waste disinfected, right. And then mechanical treatment includes shredding, grinding, and compacting waste to reduce volume before your final disposal, often combined with other treatment methods like autoclaving or chemical disinfection. And then land disposal. This is mostly commonly used. Either you have a secured landfilling or you may have an encapsulation. So this treated waste, basically ash from your incineration, is buried in sanitary landfills. There are some designated area also in many places where this particular this secured landfilling is being done, and encapsulation sharps and hazardous wastes are embedded in cement or plastic containers before its disposal. And selecting appropriate treatment methods, biomedical waste can be managed effectively. So what we understand is you have a number of methods, whether you talk about those starting from those chemical treatment, temperature mediation, and then you have this sort of land disposal sort of thing, or maybe biological. But one thing is that selection is very important, because you need to know initially that what is the nature of waste, and then only you can make all those decision. And definitely if you can do that, definitely you will be able to reduce your environment as well as your public health. So these are those definitive structure. If you talk about your irradiation, whether you talk about those mechanical treatment or whether you talk about those land disposals. Now there are few technological advancement is also being done in this particular area, because this is a huge amount of waste. I already mentioned in the very beginning that even in India it's a how many tons of it's a huge amount. So once you have that, definitely you need some sort of technological advancement or those technologies which can address this particular issue of this particular medical waste. So with increasing waste generation, as I mentioned, and environmental concern, technological advancement have definitely played a very crucial and pivotal role in waste management, whether you talk about recycling and disposal. And innovations in automation or maybe using artificial intelligence or biotechnology and smart waste solutions have significantly improved this waste segregation treatment and your sustainability. There are few attempts have been made using your Internet of Things enabled smart bins, but these are all in experimental stage, and there are very smart cities where these are being used. So these smart bins with sensors monitor waste levels and send real-time alerts for collection. Once it reaches that particular the capacity, immediately it is going to give or send a signal to that particular authority for for making that sort of provision for taking this particular waste, and reduces unnecessary waste collection trips, saving fuel and operational cost. Definitely this is very important. Example in Big Belly in United States and Smart Bin India and European Union, they are also coming up in joining hand together to come up with some sort of smart bin like that with this particular methodology. Then you have your artificial intelligence and machine learning for your waste sorting. So this is, as I mentioned, these AI powered robotic arms, sort recyclable and non-recyclable waste, and machine learning algorithms analyze basically the waste patterns and optimize your disposal strategies. These are basically in some of your Scandinavian countries like your Gen Robotics in Finland, and in the United States you have your AMP Robotics who is capable to segregate those sort of waste material once it is being there, definitely based on those sensoring mechanism, definitely it has that sort of capacity. So as I said, those in this category, you have another technology which is available, plasma gasification. So this plasma gasification basically converts biomedical and hazardous waste into your syngas. We already mentioned during your plastic waste, handling plastic waste, slag and energy using high temperature plasma torch. But it involves definitely high temperature. It can be, maybe maybe to the tune of 2500, 3000 degrees Celsius, or maybe more than that. But definitely it is having a minimal emission, used in Japan, United States and in Germany. Pyrolysis and gasification, we all know that this is a very, very common technology which can always be used, particularly breaking down that particular waste in high temperature, either in an oxygen free environment mostly, and then produces bio-oil, gas and char, reducing your reliance on fossil fuel definitely. And then AI driven waste management and recycling, this is automated waste segregations, just similar which I mentioned, that these are all artificial intelligence driven conveyor belts in recycling plants, automatically identify plastic, metal, glass and organic waste, and speeds up the process of this waste processing and improves your recycling efficiency. There are a few examples in United Kingdom. You have one company which does this very efficiently, recycling, and then another is Grey Parrot AI in European Union. Then you have your blockchain for your waste tracking basically, and this basically ensures your transport tracking of hazardous waste disposal, which I was mentioning about those barcodes and labeling. For that, labeling is must, and reduces illegal dumping and improves accountability, because one can track that where it is presently located. So there are these are your sustainable waste to energy technologies. We mentioned that waste to waste incineration for your energy production, biogas, anaerobic digestion. These are commonly methodology which can be used, and then nanotechnology can be used as well in waste water treatment, or those particular during your storing or washing those materials, whatever is being coming up. So definitely those nanomaterials are coming up which can remove those heavy metals, bacteria or toxins, and improves efficiency of water purification and reuse. And also robotics and waste collection and recycling, I already mentioned those particular automated waste collection vehicles are there. These are all basically GPS enabled and self-driving garbage trucks which can optimize your waste collection routes and reduces your fuel cost. And drone surveillance and illegal dumping. Drones basically monitors these landfills, industrial zones and forests to detect this illegal waste disposal, which is very, very important. And in all of these, which is very important, is your record keeping. Means record keeping, whether it is a healthcare facility or whether it is a research station, they need to maintain these records with reference to the category of waste which is being generated and what is the way out they have made, particularly with that particular waste. And category waste of waste, this is this is being done, particularly that inventory is being made, and this is category wise quality as well as the quantity, right? And register logbook I mentioned, which is very important. A weighing machine as per the specification given in your CPCB guidelines for your barcode system needs to be kept. And this basically these healthcare facilities having less than 30 beds shall maintain a record recipient printed by these particular authorities. And then records on annual report on biomedical waste management which is being submitted to your CPCB. So all these has to be complied with the regulatory authority. That means this record keeping and compliance with those regulatory authorities is very, very important. And once anybody, particularly who is responsible for generating this waste, whether it is those healthcare facilities or those research stations, so definitely, or those pharmaceutical company, so they have to maintain all these records in complete format. Otherwise, the management issue, one cannot use it properly or rationally. One cannot plan for that rational planning for this waste management. So in today's class, so what we have learned is definitely we have learned that particular different modes of collection is there. That is one important part we have learned yesterday. And then we have learned that how to store it. And then the very important component is your transportation of this waste, and what are those basis necessities, whether you follow your CPCB or whether you follow your State Pollution Control Board, what are those necessary prerequisites that is going to be maintained, as well as we have also seen those particular the mechanisms for this particular waste which is being generated, how to get rid of that. So what are those options available, those different technologies which are available, whether you talk about conventional technologies or whether you talk about those sophisticated technologies. So we have also detailed on that particular part, and also we mentioned that particular maintaining that database is very, very important, because because this is going to help you once you are maintaining this particular portfolio management, which is very, very important, particularly keeping this track as well as addressing these issues of waste management. So in the next class we are going to deal with mostly with those regulatory compliances and what are those provisions and legal provisions in your next class. So thank you very much.